So the goal of this video was to develop a BFO using a field effect transistor, and of course this Hallicrafters S120 was the volunteer to get the BFO. This has been done before. There are some articles on the internet that show people using small solid-state BFOs in this receiver. Unfortunately, most of them simply turn the BFO on, and you have to tune the BFO by taking the cover off the radio and adjusting it. And you can usually get it to work quite well on CW, but on single sideband you either have to pick upper sideband or lower sideband because you don't have a front panel adjustment. So one of the constraints of this video was to try to use this BFO control as a variable frequency control for the BFO, so we could tune the BFO using the potentiometer through a varactor. And that turned out to be a lot tougher than I thought it would be, because getting a ceramic resonator to cover a wide frequency range required a varactor and a wide tuning voltage. I had to have about 24 volts DC to tune the varactor enough to make it useful to go to upper or lower sideband. So getting a couple kilohertz out of the ceramic resonator turned out to be quite a job. But we did get there. It's not pretty, but we did get there. So turning it off turns the BFO off.
Comunes para allá, para aquellas áreas, no allá para el sur.
The BFO is passable, at least for CW, but on single sideband it's pretty tough. You know, it's not a great BFO. The AGC obviously can't handle it.
Pero los mentados frijoles charros.
Now we're injecting the BFO right at the detector diode. We're not injecting the BFO back at the IF or dribbling it in with a gimmick capacitor or anything like that. This is direct injection right on the diode. In the middle of the 200 MVAs window. In the middle of our house, it has a crown. There's always something happening. So welcome to part 2 of our BFO adventure. In this video I'll be doing an FET type oscillator that's using a ceramic resonator. So no tunable coil, no IF transformer used as a either an Armstrong or a Hartley. This is going to be a ceramic resonator based oscillator. And the target receiver for this project is the Hallicrafters S120, which is kind of the culmination of 40 years of Hallicrafters high technology of AC-DC receivers, using the All-American 5 tube lineup basically, and making a general coverage shortwave receiver out of it. Now it turned out that the S120 was an adventure on its own. There's a lot that's been written about the S120, restoring it, modifying it, using it, getting shocks from it, and so on, because it is an AC-DC set with no transformer. But a lot of fun working with this receiver on this project.
and it kind of hogged the whole video, actually, more so than the actual BFO itself. So I hope you enjoyed this video on part 2 of BFOs, and hope we can get this thing working without me getting too many shocks. I wanted to show you guys some fan art I got from Jim Whitlock, WA4QKV. Jim is a wonderful artist. He's been painting since he was a kid, and I don't think he's a kid anymore, but take a look at this. I don't know if you can spot the various devices in the picture, but he's got this cup with WU2D on it and a BC348. Looks like an ARC5 transmitter, some kind of power supply, and there's a winter scene out the shack. We've got the ladder line going up. This is fantastic, and I really want to thank Jim for sending this, and this is really something special that I'll be hanging in the shack. So initially I started with these two circuits. Oh, I see a mistake already. This diode's backwards. That diode should be going down. The circuit to the left is a Pierce oscillator. I breadboarded it. It came right up. Pretty forgiving of the choke value. Anything from about 450 microhenries up to 2.5 millihenries work fine. The problem is I did not get a lot of variation using the variable capacitor. It just wasn't giving me much variation at all. My goal is to get at least 2 kilohertz so that we can do lower and upper sideband, or at least try to get each side of 0 beat. I went to the circuit on the right, and the circuit on the right is a standard Colpitts style with a clap style tuning on the bottom of the resonator. That also gave limited tuning, a lot less tuning than I thought I would get using that technique. However, when I grounded the resonator and put the capacitor across it like this and grounded this, I was able to get over a kilohertz, and things were really starting to look up. So basically the circuit started to be rearranged, and it was parallel tuning that gave me the best performance. So that's the route I took. I went with the Colpitts, where I could adjust the feedback with these two capacitors and optimize. It gave me a lot more flexibility than the simple Pierce oscillator. And I went with a parallel tuning of the resonator. The circuit to the left is all over the internet. You'll see it. It's a very simple Pierce oscillator. However, sometimes they have it misdrawn and put the bypass capacitor right on the drain, which of course shorts it out and it doesn't work, and then people wonder why it doesn't work. I built this up and it works very, very nicely. Puts out a good strong sine wave. So as you can see, the sine wave's not perfect, and there's a lot coming out. That's a 10x scale. We've got a lot of output, unloaded of course. Now I'm going to add the diode on the gate to ground. As you can see, as soon as you add the diode, it goes down. Let's take a look and see what's happening. The diode is limiting the excursion. As you can see, it cleans up the sine wave. So that's what that's all about. So I've been fooling around with the circuit a little bit, and I tried the capacitor off the end of the resonator, and it was way high. So I've got the resonator grounded now with no capacitor, and we end up at 456,573, which is on the high side. So that would be good for low side LSB, lower sideband, as a BFO, and I'm going to try the capacitor across the resonator next, see if we can get some tuning. So we now have the 100 picofarad capacitor right across the resonator. The resonator is grounded off the gate of the FET. And let's unmesh it. And let's see what we got for frequency. 456.1. And now we're going to tune the capacitor. It's coming down. And we can get as low as 452.4. So we're talking about, 3 kilohertz of swing. That's probably usable. That's a lot better than the series connection we had. And it allows us to get right on 455 for 0 beat. Which is nice. There we go, 455. So I think that's usable. So I can say that this BFO project turned out to be a lot more than I thought I was going to be doing. When I started, I thought it would be some simple little circuit like this, where we just had, a Pierce-type resonator, and I'd stick some capacitors at the bottom of the resonator, and we'd be in business. But it turned out to take quite a bit of circuitry to tame the ceramic resonators, and I had to use a lot of tricks in order to get a wide enough tuning range so that we could get a couple kilohertz at least of tunability. My crazy goal here was to actually use the existing potentiometer and switch in the S120's front panel and not have to modify the radio. So that potentiometer is 1.5K and it has a switch on it. 1.5K is not an ideal value. You'd rather have something like a 5K or a 10K, because if you're trying to control a varactor diode like this MV110 that I'm using, you'd like to have about 20 volts to work with. And getting 20 volts from 110 volts DC that the radio provides means you got to have a pretty big dropping resistor. You're going to waste about 10 milliamps of current and all kinds of bad things. If that were a 10K pot, you'd only be wasting a few milliamps, and so it's going to be a strain, and we'll see if that works at all. The circuit worked just fine from about 5 volts all the way up to 20 volts, but I decided to run it on the 6 volts provided by the cathode of V4 in the radio, which is about 6.4, 6.5 volts. So I've got a 6.2 volt Zener there. We'll see how that works out. So we've got a very complicated solution to the BFO, and far more work than I thought I wanted to do. But I am trying to inject, or I will try to inject, right at the diode, not at the IF stage, but right at the diode detector that's in the 12AV6 V3. So among the tricks that I've used, I'm using a fairly large capacitance varactor. I'm using a Colpitts oscillator and 2 resonators in parallel. When you put 2 resonators in parallel, it allows you to get a little bit more rubbering, and by rubbering I mean being able to vary the frequency of the resonators. And it also does something that you might not know, and that is it increases the frequency overall. I wanted to make sure that the thing would tune well above 455 kilohertz so that we can do lower sideband. And by adding the second resonator, it seemed to make the oscillator much happier, sometimes when you're trying to pull these resonators, the thing will just stop oscillating completely. C3 and C4 set the feedback, and they also, of course, affect the frequency range. So you'll be fooling around a lot with C3 and C4 if you actually try to build this thing. So this was really way more work than I wanted to do. I'm going to vary that potentiometer, and we're going to look at the frequency display. So let me see what we can get out of this thing. This is with the 20 volts on the varactor. So it looks like I can get up to 456.4, so that's about 1.4, almost 1.5 kilohertz above 455. And the other way, I can go down to 454.4, so I can go, you know, about half a kilohertz lower than 455. Not the greatest, but that's about the best I could do. We'll see how that works in the radio. Well, we've got a Hallicrafters S120 receiver, which is kind of the end of the line for the S line. Oh, I guess I shouldn't have said S line. That's the Collins. Well, the S38 and family. And to deal with a receiver like this, and you have to realize this is a simple AC/DC type receiver, you've got to be extra careful because these things can literally kill you when you come between the chassis and a good ground if the cord is pulled down. We have to be very careful working on the receiver and use an isolation transformer, and I'll show you that setup. There's not much to get the radio refurbed beyond the typical cleaning and contacts and taking care of the dial string and the rest of the lubrication. You've got a few parts you should change. First of all, the electrolytics, there's 3 of them, they'll need to be changed. The selenium rectifier, which is the rectifier for the receiver, is probably bad, so you need to replace that with a diode. And then because the semiconductor diode has less drop than the selenium, you need to put in a resistor to drop some of the voltage, and it's a modest size resistor of you know, about 22 ohms and something that's a little more than 3, 4, 5 watts. This guy's a 10 watt, a little bit overkill, but it'll be fine for the receiver. So this is an isolation transformer. It's a 1-to-1 type transformer. In this case we're putting 120 volts AC, 60 hertz in, and that's what we want on the output as well. But it isolates us from the neutral and the hot of the line. So with an AC/DC set like this one, especially one that's got, looks like a homemade cord's been put on this, that's very dangerous because anywhere on this chassis that you contact, one of the controls or whatever, if you get between that and hot somehow, you're going to get a shock. So one thing we're going to be doing is replacing the cord with a properly polarized 2-prong style cord. Now we have to make sure that this fatter prong here is neutral. Okay, we're looking for the neutral on this cord. We'll be measuring that. It's tricky though, because how do you know that every outlet is wired properly? And the only way to do that is to check it. So these things are inherently dangerous. You're depending on the isolation between the chassis and the ground in the set. The antenna terminals and the ground terminal that's on here where you attach, they are isolated, but insulators can break down, so we have to be very careful with a set like this. And indeed, all the AC/DC sets that start to age can begin to leak through their capacitors. They can begin to break down through their insulation, even through the terminal strips. So the S120 seems to have a variety of both Black Cat and Black Beauty capacitors, and any one of those could be leaky and possibly cause problems. The most important ones are the ones that connect between the chassis ground and the ground return used for the AC/DC. where it could literally light up the chassis and get you in real trouble. So we'll be looking at the capacitors that are in the places that can cause safety issues. First, I'm going to be using an isolation transformer just for safety at first. I also see a selenium rectifier in there, and I will probably change that out to a diode, a silicon diode with a series resistor, so that we don't put too much voltage on the stages. The selenium rectifier has quite a bit of loss compared to a regular diode. So step one is just to get the radio back to its normal working condition. There has been a lot of controversy as to whether the S120 and its kind are actually connecting one side of the power cord to ground, to chassis. Chassis. Okay, let's talk about chassis. What is chassis? This is the chassis. This is what we call the chassis. Now ground, on the other hand, is the AC ground for all of the circuits. When we talk about RF circuits, audio circuits, the AC ground is floating in this radio. So if you are to use a ohm meter, I'll just prop the ohm meter up here so maybe we can see it, and we measure from one side of the cord to the chassis, okay, what we're going to find is that we have a half a meg, 552K. Now, if you look at the schematic, you can see right here that they are indeed tying the chassis to ground through a 470K resistor and a 0047 600 volt capacitor. So that is the connection between chassis and ground, and that's a safety measure. Now, if that capacitor should short out, now the cord will be connected directly to the chassis, and it would be a big shock hazard. But there is a safety system in here. Now, they also have this back panel, and people claim this protects you from touching the chassis, so that's another way of protecting you. Well, not really, because the front panel and everything else, it basically can accidentally come in contact with the chassis. They put a little fiber board here to try to disconnect the front panel from the chassis, and there's another, that's, just another attempt at safety. So there's some paint on the chassis. That paint is another way to protect you from getting a shock. All of these are kind of weak safety measures. So what a lot of people like to do is they like to replace the plug it happens to come with a polarized plug, and convince themselves that by plugging it in with a polarized plug, that's going to give additional safety. So really the most important thing with this radio as far as safety goes is to replace those capacitors, specifically C29, the 0.0447, with a new capacitor that has at least a 600 volt rating, and that would be the best thing to protecting yourself. If you want to go as far as to use an isolation transformer, that would be a good idea too. But this receiver is completely safe as long as the capacitors are in good condition. I don't see anything wrong with the way that they have this hooked up. It looks like they are attempting to switch the one side of the line through the switch. I don't have any problem with that. And one side of the line is connected to ground immediately. That could be useful because we could probably put a neon bulb and a resistor in there, and that might be useful to tell if your hooked up to neutral, if you were to put in a 3-wire cord, you could at least have a safety system that would alert you that the line is putting the hot onto the side that goes through that 470K to the actual chassis. So if we want to go as far as to do a 3-wire cord, we could add a neon bulb in there that would alert you to an outlet that's not wired properly. I don't think it's worth doing all that. Maybe putting in a polarized plug is a good safety measure as long as you know that the plugs are wired correctly, or you buzz it out and you make sure that the radio stays plugged into the same outlet all the time. But the real protection is the separation of the chassis ground from the AC ground in the radio, or the RF ground in the radio. So the purpose of this video was not to show you how to restore an S120, but I did want to use the S120 as the guinea pig for a BFO because it has such a poor BFO circuit. They literally take the IF stage and make it go unstable and turn it into a self-oscillating IF amplifier, and it's very clever. It saves a lot of parts. It allows them to use just a simple potentiometer and no variable capacitor at all. But I wanted to first get the receiver into a safe mode, and of course what's recommended is that you put a polarized AC plug on the front, and you know, the polarized plug has the larger blade on one side. Now that larger blade is your neutral, and that goes to the ridged part of the cord. You can see these ridges here. The smooth side is the hot side, and that goes to the small blade on the plug. So you're going to put the cord through using the same original nut that's on the receiver. It will fit. It's a little bit bigger, but it will fit if you squeeze it and pop it in there. The one with the ridges is going to go to the quote-unquote ground side, and that ground side is the top of the pot here, and that is connected to ground. It's a strange place to put the AC cord ground, but convenient because the other side is going to go to the hot side is going to go to the switch right down here. So made sense to put it there, I guess. And they have a wire that comes over to the common ground from that point on the potentiometer. So that really is the AC or the RF ground. People argue back and forth, is this a hot chassis radio? Well, it depends on the definition. By definition, with no transformer, it is a hot chassis radio, but the chassis is not that hot because it has a 470K and a 0047 600 volt capacitor that connect the chassis to the AC and RF ground. So that's enough limiting that it will give you a tickle if you came across the chassis and a real ground and it was plugged in wrong, but it's not going to kill you like if it was connected directly with a bus wire between chassis and ground. So they've taken precautions to isolate, for instance, the front panel from the chassis, the back of the radio, your hand from the chassis, and so on. But really, the things protecting you isn't just that. It's the fact that they have that 470K and the 0047 between the two grounds that provides some safety bias. Now, will you feel a tickle? Absolutely, you'll feel a tickle. It'll scare you, but hopefully it's not going to cause you to have a lethal or near miss, as we call it, type situation. I want to show you a method of injecting BFO into the receiver. We have a piece of coax coming in. It's grounded at the AC ground at this point, and then we have the center conductor going to this orange wire that's simply wrapped around the first IF's grid wire from the IF transformer to the grid of the tube. By wrapping 3 turns of wire around here, we're producing a capacitive injection called a gimmick capacitor. And that's how we're going to inject using our generator first to see how much injection voltage we would need and how effective that's going to work by just trying to inject the BFO at the input of the IF. So I'm injecting 444.5 kilohertz in. So this is my external BFO I'm bringing in from the generator. Anyway, I'm just getting a beat note here for some CW. Anyway, this is 40 meters, and what I'm finding is a couple of problems with this receiver injecting BFO. First of all, it doesn't have any RF gain control, so it's extremely easy to overload the receiver on strong CW signals, and its performance on single sideband is not good at all. The advantage that the solid state receiver had over this is it had a pretty good automatic gain control system. When you go to BFO on this with this control here, the first thing that does is it puts a 470 ohm resistor right across the AGC, effectively shorting it out. So it sets the gain almost at maximum for CW. So this receiver would work very well if you had a poor antenna, like just a 10 or 20 or 30 feet of wire. But when you put it on a full-sized antenna of any kind, or even a tuned ham antenna, the receiver overloads so easily that you really don't get a good performance, and CW becomes difficult, single sideband almost impossible. So you need to put an RF gain control or a variable attenuator in front of the receiver in order to make it work as well as that ICOM receiver did with just injecting some BFO in very easily. So with no RF gain control, this is a very difficult receiver to get to work by just dribbling a little bit of BFO energy into it. So we're taking the very conventional AGC detector and we're splitting it using one diode as the AGC and one diode as the detector. And now we're going to add a third diode. This third diode turns the AGC into a voltage doubler in effect, and this two diode circuit makes more sense if we redraw it using semiconductor diodes. And we're going to inject right at the detector diode, right at pin 6. Okay, I have a fairly strong signal around 2.6 megahertz. It's around minus 75 dBm. And I'm getting a certain automatic gain control number of minus 2 volts with our modified AGC system, where we have a separate diode for the AGC and using the other section of the 12AV6 detector audio amplifier as the detector diode. So we've split the diodes. And I can turn on modulation. It doesn't seem to make much difference in the level. Now what I'm going to do is insert a diode and form a voltage doubler type circuit that will should increase the AGC output, make it a little more sensitive. The receiver seems to have excess gain when hooked up to an external antenna of any size, So I figure a little extra AGC would not be a bad thing. Let's see if we can calm it down a little bit. Okay, we're using a Schottky diode, a 5711 HP. It did not double the voltage, but it brought it up 800 millivolts, higher than the 2 volts we had before. Now we'll try a germanium. The germanium also gives an increase, but only about 500 millivolts. So the Schottky wins. How do you like that? So we've got some distortion, and it's interesting because shouldn't have it. All I'm doing is putting my finger on the speaker. Let's try an external speaker.
Options at mycatholichealthcare.com.
So there you go. It's just a bad speaker. So you can go chasing your tail on these things and looking for distortion. It turns out just to be the speaker is just damaged or old. Needs to be replaced.
The rivalry. No, that's not the words. What's this word? The Hatfield and the McCoys. What was that? That was a.
Okay, this is with the AGC working.
Feud. Yeah, the feud.
And of course, AGC shorted out.
The great ones in the country.
AGC in.
And the hatred that the senator had for the president is evident.
Okay, let's try upper sideband now. This is aviation weather just below the 80 meter band.
Visibility 10 kilometers or more. Clouds at 2,000 feet.
So we're able to do upper or lower sideband from the front panel. So this video is really experimental in my mind. I mean, seriously, the recapping and the safety measures, the tune-up and all of that with the S120, absolutely valid. You might want to play with the AGC like I have. That might be worth doing. But the BFO part is pretty experimental. And of course I was not happy with the way that I had to tune the ceramic resonators, having to come up with that 24 volts or 20 volts to tune the resonator in such a brutal manner by using a Zener and wasting 15 milliamps essentially, just making a bunch of heat in the radio. There's got to be some better ways. So I'd really suggest that you use a tune type transformer type BFO rather than the ceramic resonator. They're much easier to tune. You could tune that on the original 6.4 volts and you wouldn't have to go through what I went through with this. Well, that's it for BFOs for a while anyway. I think we've covered it pretty well. And I've had enough of these AC-DC type receivers. Really is challenging, and what they're able to do with 4 tubes is absolutely amazing. Hallicrafters has to be commended. But trying to make the receiver work with the existing controls with no modifications with our BFO turned out to be quite a challenge.